Welcome to another exciting segment of Math with Miss Bennett. Today I'm going to be talking about equations. An equation is a statement that two expressions are equal. Equations are the ones we like more than expressions because equations can be solved. We want to know the value of x. It's just our nature, and in equations we can do that. Equations are all about balance. They're almost like toddlers. You see, if you were pouring juice into cups for two toddlers, those two toddlers would want to make sure that the juice lined up exactly the same. And that kind of is a reminder of the cardinal rule of equations, which is whatever you do to one side of the equation, you must do it to the other side. And I'll give you some examples of that in a minute. Next piece, though, we need to talk about inverse operations. These are operations that undo each other. Some people think of them as a lot like opposites, but I prefer undo. So let's talk about inverse operations. And the inverse operation for addition is subtraction. The inverse operation for subtraction is addition. The inverse operation for multiplication is division, and the inverse operation for division is multiplication. It's very simple and easy to remember. So let's get on to solving some equations. This is where the rubber meets the road, so to speak. What do we do? Now, you guys are smart, and you probably have in your mind an idea for the answers already. And this isn't bad. What I'm going to show you in this solving process simply allows for you to have a method that will work to solve any equation in the world, no matter how big or messy they start to look. So bear with me if this seems to be a little bit extra. You'll see why as you progress through algebra. Also, the same method applies to solving inequalities, which will be our next video. So looking at this first equation here on the left, we see our variable is x. And when we solve equations, we kind of have an internal dialogue we think through. There's our x. What happened to the x? Well, we added 5.2, and when you add 5.2 to x, you get 9.1. So what we want is we want the x to be alone at the bottom of the equation. We want the x to be isolated. So how can I isolate that x? How can I undo plus 5.2? Well, the inverse operation of addition is subtraction. So I'm going to subtract 5.2 from both sides because equations are like toddlers. They like everything to be fair and balanced. This is going to be like my equal sign. It just separates the work. So x plus 5.2 minus 5.2, if I add and subtract the same number, I get 0. And I'm going to put this in green because this 0 is totally optional. Do you really need to write plus 0? No, we could just skip straight to x. X and 9.1 minus 5.2 is 3.9. And there you have it. You've algebraically solved the equation. The solution to the equation is x equals 3.9. You could go back and put in a 3.9 here and mentally figure 3.9 plus 5.2 equals 9.1. Let's solve the next equation. Here's our variable x. It's located in a different place, but that's okay. It doesn't have to be at the start. We have x minus 22.7 is equal to 5. What's the inverse operation of minus 22.7? That's addition. So on both sides, we're going to add 22.7. Doing this will eliminate the x. Doing this will eliminate the operation on the left, the right, and give us the answer on the left. So let's see, x minus 22.7 plus 22.7. If I add and subtract the same number, I get 0. And I'm doing that in green because it's kind of optional. And then 5 plus 22.7 is 27.7. So the solution to the equation is 27.7 equals x. I got the x isolated or alone. That's all I want. And if I wanted to check my work, I could go back to the variable and put in 22.7, and put in 27.7, and I would find that 27.7 minus 22.7 equals 5. So you can prove that your answers are right. It's the best thing about algebra. You never have to wonder. You can always know. All right, we got 2 more equations here. Now these are where students start to get a little bit uncomfortable because we use the algebraic things. We use the fraction bar for division, and we use a coefficient for multiplication. So you're not going to see your traditional multiplication or division symbol. So let's look. Here's our variable x. What happened to x? Why is it not alone or isolated? Well, it has a 4.1 next to it. That means we multiplied it by 4.1. I want to get rid of the multiply by 4.1. I need to use division to solve. Instead of using the traditional division symbol to show my divide by 4.1, I'm going to do this more algebraically and use the fraction bar. So while it means the same thing as what you have here, you'll see it instead as a fraction bar. Now that both sides have been divided by 4.1, it's fair and balanced. X times the same number and divided by the same number. Well, if we multiply and divide by the same number, we get 1. And 1 times x. On the other side, we're going to get the answer. And in this problem, we get 33.62 divided by 4.1 is 8.2. What's great about this here is 1 times a number is just x, just the number. So we have the solution to the equation. X is equal to 8.2. If you wanted to check your work, you could go back and plug in or substitute that 8.2. 4.1 times x, which is 8.2, is equal to 33.62. And we have found the solution to the equation. Remember, this symbol means divide. All right. For the next equation, we see a fraction bar, and that makes some people uncomfortable automatically. But I want you to read that fraction bar as a division. So this is really x divided by 12 equals 18. That's not hard to fix. We need to undo the divide by 12 to make it just x. The inverse of dividing by 12 is multiplying by 12. Now this is where things get a little bit messy because it's kind of hard to throw in a multiplication without the old multiplication symbol that we're all comfortable with. So what a lot of math teachers do is they use parentheses. So they show everything needs to get multiplied by 12, and they use parentheses instead of the multiplication dot. I'm going to put that dot there for now, but it's totally optional and most teachers won't do it. All right. So when we look at x divided by 12 and multiplied by 12, 12 divided by 12 is 1. So I'm going to get 1 times x equals 18 times 12 is 216. The great thing about this is that 1 times x is really just x. So I have the solution to the equation. X equals 216. I could solve this by going back and plugging in or substituting 216 for x, and 216 divided by 12 is equal to 18. You have solved equations. Now remember, it's all about inverse operations, undoing what you see that happened to x, sort of by using the opposite, if you want to think of it that way. to get rid of the operation so that x is alone or isolated. And remember, whatever you do to one side of the equation, you must do to the other. It might feel like extra, but it is important to maintain algebraic balance. Well, this has been an exciting segment of Math with Miss Bennett. See you next time.